About precise measurement, I will talk about. This is what most of the physics laboratories do, and we'll talk about that. Suppose you want to measure a time period of with a higher precision, say up to 4 decimal places, but you have a measuring instrument with only 1 decimal place. So I have a stopwatch which gives me a 0.1 second least count, and you want to measure something with 4 decimal places. What will you do? You'll measure the time period for 1000 oscillations. Okay, so say for example, time period for 1000 oscillation turns out to be say 2458.2 seconds. Okay, you do it multiple times, and then suppose you got this average. Then you know that one oscillation will be 2.4582 seconds. You have measured precisely 4 decimal places by taking large number of oscillations. This is what exactly Arabet realized, and he said starting stopwatch, stopping stopwatch precisely becomes important. You need not keep noticing all that precise time for each oscillation. How many oscillations are done is important. So starting, stopping is important. In between, you only have to count how many oscillations are happening. So you need not keep watching for 1000 oscillations. You know, I have started this oscillation. Then every oscillation, you should know that okay, 1 oscillation is done, 2 is done, 3 is done. In order to make precise oscillations in physics laboratory, people use telescope to precisely see how that pointer is moving. But in between oscillations, you need not bother. As long as you are only measuring, counting, that is sufficient. Now, that is where this becomes relevant when you start measuring periods of planets. So, you know, a planet has done say 100 oscillations or 100 revolutions around the Earth, or you may have seen that planet has done some 1000 revolutions. Okay, then at what point it started, in which nakshatra it was, how many degrees in a particular nakshatra it was, and today how many degrees at a given time it is. These endpoints become very essential, and the information that it has completed so many number of oscillations. So this information is good enough to do precise calculation, and that is where we need to understand that the starting point, the end point measurement, and approximate period of oscillation, that is sufficient to make more precise calculations. There is another method that we use today. We'll see how it becomes relevant there for precise calculation. Suppose you want to measure a oscillation of a pendulum whose period is some t. You want to measure its period precisely, but you don't have another precise stopwatch. So what do? Suppose you have another pendulum whose period you know very well here, and that period is t prime. Now what will happen? You can start both pendulum together. So slowly one pendulum will start lagging behind, and after multiple oscillations, okay, again there will be a time when they will come together. So one can write mathematics, and one can precisely then calculate what is the time period of one object, one pendulum, with respect to another pendulum. This is called coincidence method. In the modern history of science, people have used this for 4, 5, 6 decimal places precision to measure the period of pendulums. How it becomes useful? It becomes useful that, I mean, I have just given numbers here that you may be able to precisely measure up to 5 decimal places, 6 decimal places using coincidence method. The coincidence pendulum corresponds to conjunction of planets. Imagine one planet is one pendulum, another planet is another pendulum with a different period, and both have come together. It's like conjunction. And after how many revolutions, again they are going to come together. That's why conjunction phenomena, noting down conjunction phenomena, which conjunction happened in which nakshatra, that is telling you that what is the phase lag or phase lead, okay, from the original position. These become very useful to precisely measure the periods. So, I mean, though we say that the ancient astronomers had knowledge about 8 significant digits, 9 significant digits. You need not have atomic clocks for that. with so much of precision when people have measured the period. What you need is long duration precision measurements and simultaneously the coincidence method. These two methods are sufficient to precisely measure the time period. Of course, what you need is people who will keep recording, and that's why you need schools which will keep recording those time periods. That I mean, you need a good assistants who can do meticulously this job. But that's good enough.